Okay, hello. Welcome to Histology 101. My name is Luke Osite, and I'm going to be taking you on a journey into cartilage today. So fasten up your seatbelts because this is going to get a little bit gelatinous, okay? Now, cartilage is an avascular connective tissue that has some clinical implications, okay? Because it means that since it lacks any veins, it lacks a direct blood supply. We see a ring of cartilage here, okay? Now, since it cannot heal very quickly and it cannot receive nutrients, what that tells us about the metabolism of the cartilage cells is that it's going to be very low. Because of that, you don't have any thick plates of cartilage in the body. It's always going to be limited by the distance of diffusion, okay? So if we look at some of the cells that we see in cartilage, okay, we see a chondrocyte here, a chondrocyte here, a chondrocyte here. Chondra is the suffix that we use, the prefix that we use for cartilage. Cyte is the suffix that we use to describe cell. Chondrocyte, cartilage cell, it makes perfect sense when you think about it like that. Now, the cartilage cells, they're in little groups like this. We call these isogenous groups. They're like little gangs, okay, little gangs of hoodlums. In between the gangs, okay, we got what's called an interterritorial matrix. That's a turf that nobody goes around. But we call the extracellular matrix directly surrounding the isogenous groups, we call that the territorial matrix. That's their neighborhood. You don't mess around in the isogenous groups neighborhood, okay? The chondrocyte itself, it sits in a little thing called a lacuna, this little white space here. That's a lacuna, and here's the nuclei of a chondrocyte. Now, let's zoom out to make another important observation that you should be able to make about cartilage, okay? You ready for this? Cartilage, recall that the prefix we use to describe cartilage is chondra. Now, I want you to look at the perichondrium, okay? Now, here, the suffix is cartilage, but peri, the prefix, means around. So we're going to be observing the tissue around the cartilage, okay? Here is the tissue around the cartilage, because you recall the cartilage is just this big blue ring right here, okay? We get to the pink stuff here. This is a completely different type of tissue made up of different type of collagen. Both still connective tissue, but this one up here, this is actually going to be vascularized, okay? So the cartilage ring here is going to receive blood supply from the tissue here, okay? This is called the perichondrium tissue. We divide the perichondrium into two sub-layers. We have the inner cellular layer here. You see what my mouse is pointing at? This is where you're going to have, essentially, you can think of the stem cells for cartilage, the chondrogenic cells. They're going to come out here and start dividing like crazy up here to form these isogenous groups. So again, chondrogenic cells within the cellular layer of the perichondrium. The inner cellular layer is very slim right here. But the outer fibrous layer of the perichondrium, look at this. And you see these are actually fibers running across my screen like this. They're compartmentalizing the cartilage, and that's why we call it dense sheet-like cartilage. Another point you got to know, don't forget this. The type of cartilage that you see here, okay, this is type 2 collagen and hyaline cartilage. Whereas the type of cartilage that you got out here, this is type 1 collagen, okay? It's very important that you do not mix up these two types of collagen. So, again, just to go over what we see here, we're in the trachea. We have a cartilage ring surrounding it. The type of cartilage that we see in the trachea is hyaline cartilage. We always suspect a perichondrium to be surrounding a hyaline cartilage, okay? We're going to have two sublayers of the perichondrium. We're going to have an outer cellular layer, which is this, made up of dense sheet-like connective tissue that helps compartmentalize the cartilage tissue. And we're going to have an inner cellular layer of the perichondrium. That's this bad boy here, and you see these little cells. These are your chondrogenic cells that are going to go and divide, and they're going to make all of the cartilage down here, okay? The chondroblast, we call them, blast meaning a suffix for a cell that's going to grow into something else, a maturing cell. The blast is going to grow into the chondrocytes you see here. We call it the chondrocytes, appear in isogenous groups like this. They sit in little white spaces called lacunae. You actually see some interesting thing in smokers that this whole layer, the cartilage and the mucosa up here, gets very thin from the damage of all this nasty smoke. But it is hope because you can't stop smoking cigarettes and it's going to grow back. So I think that's all I want to show you for the trachea today. Just to throw you for a little bit of a loop, I'm going to show you what it looks like in a little wee baby. Yeah, freaks you out a little bit, okay? This is actually a fetus, okay? A fetus pig to be specific. This is the tongue, quite a big one on this guy, and this is actually the nasal septum. Now, the nasal septum, put your finger on your nose and you can tell it's made of some cartilage. Here, we just call it condensed mesenchyme, which is a fetal type of connective tissue, okay? We zoom out a little bit, we're also going to see something called Meckel's cartilage down here. Condensed mesenchyme is the word we use to describe cartilage within the fetus, okay? It's not fully formed. Now compare it again to what we just saw here, okay? It looks almost nothing like this. It's very basic. But now if we compare this to what we see in a slightly older baby, you might know some older babies, this is a later stage of a fetus developing some cartilage. You can see the extracellular matrix. It's like a little more basophilic. We have some development of the lacunae, again, the white spaces, which the chondrocytes sit. And you see this compartmentalization. This is the perichondrium, okay? This is a really fundamental part of biology that you got to get into your mind. That compartmentalization, localizing things on both the macroscopic and microscopic level is so important for biology to work. It is all compartments, all organized compartments that allow a biological system to work in harmony. So, and if we just take another cool look here to see some other fun things in this fetal tissue, this is actually the basis of fetus bone. Can you believe that? Now, this develops from a type of tissue in the embryo that we call the mesoderm. And this bad boy here, can you take a guess what this is? This structure here. And if you got a really astute eye, you would see this shape and you'd be, what does that look like to you? That looks like a tooth to me. And if you guess that, you'd be right. That bad boy is a tooth. So thank you for coming today. Goodbye.